Good morning. I gotta go over there. Subscribe only chat? Oh, no, it's not. Let's turn the air conditioner on a little bit, and I want to tell you about a great quality of life improvement I made. Okay? You see this? You see this cable? This used to be the cable connecting the Tenstorrent computer. But the Tenstorrent computer was loud. So we banished it to another galaxy. Now, by the power of SSH, we can still access it. But it's not in this room being loud. And hopefully, with the loud computer gone, we can hear ourselves think. I think also, there's a bit of a misunderstanding. George, the documents say you're supposed to use Ubuntu 2204. I would recommend sticking with what the documents say, okay? And IQ curve mid. You guys know this meme, right? You guys know this meme, right? Everyone knows this meme? Right? Know your meme? Everyone knows? Yeah, so it's a misunderstanding of what we do on this stream. Some people believe that the goals of these streams is to accomplish something. And then I ask yourself, have you ever hung out with your friends? Maybe you smoked weed and watched Mel Gibson's The Passion of the Christ. That's a good time, right? Now tell me, what were you trying to accomplish? Exactly. That's the mentality that we have to have on these streams. Because if you're trying to accomplish goals, it's just like, I might as well work in a high frequency trading firm, right? No, but you don't understand. We do price discovery. We make markets more efficient. No, you don't. You play a zero-sum game, waste the intelligence of a society, and siphon money away from the middle class. But you don't want to stare into the abyss and tell yourself that. So you really like it takes a certain amount of staring into the dark abyss to understand that just because life is meaningless and there's but we could do this. Why don't you use Ubuntu 22? No. We're all just here to have a good time, and then we're gonna die. Even Brian Johnson, even Ray Kurzweil. Yup, because, you can escape death forever, but then the heat death of the universe is gonna get you. So everybody take a minute this morning to realize that you're going to die. Okay? You are going to die. I'm going to die. We're all going to die. Everything you've known and loved is going to fade away, and it's all going to be meaningless. So why the fuck do you work at a high frequency trading firm? That's just... But no, I need a $400,000 salary so I can keep my wife around. Well, you picked a bad wife, bro. That's you shouldn't have picked a wife like that, You gotta put women through shit tests, man. Take them to Arby's. And if they're not cool with Arby's, you shouldn't marry them, okay? That's just good life advice. Okay, I mean, did your father tell you that? No, you were raised by a single mother. I'm sorry. I have to check my privilege. Everybody knows that. No, Arby's is fucking disgusting, man. Okay. All right. But if your girl won't go with you to Arby's, you shouldn't marry her. And stop doing high frequency trading. You're wasting your life, and you're gonna die. Chipotle is actually pretty good. See, but this whole and all society wants you to have this goal-oriented behavior. Oh my God, machines of ever-loving grace, there's something so spiritually wrong in Silicon Valley. We're gonna build this machine that's gonna take your job away. Oh my God. No, one of my favorites. There's a 0 HP Lovecraft post taking down leftist rejection of IQ. I don't know, we could go into it, but it's just like everyone knows that you could have a dumb guy and he's a great friend and he's a good guy and you like having him around, right? Right? It's not like it is only, or I don't know. I got into it with this woman, like she genuinely believed that people with more money were better people. And that's at the absolute core of it. She actually believed that, and I don't know, you've let the capitalism into your heart. I mean, it's probably true, but do you know what I mean? It's not like it's a good-hearted metric, right? Someone who does high-frequency trading to make money is a bad person, right? There's an amount of, oh, well, I made money by providing goods and services to other people. I created value for a lot of other people, and I took a small percentage of that value. Okay, great. That you're actually a good person then, right? You're creating value for other people. Versus, well, you see, every time Peter pays Paul, I took 3%, and then I traded an option on a derivative of that 3% and took 0.1% for myself. It's it's the plot of Superman 4, with the stealing pennies. I never actually saw Superman 4, but I saw Office Space where they referenced it. So, just everybody really think about what you're doing with your life, because you're going to die, okay? All right? Dude, ketamine is dirt cheap. Go to Vietnam and go to a veterinary clinic, and why are the weird white guys coming in here and buying ketamine? Fuck that printer. That's right. All right. Yeah, but in order for things to have meaning, you have to first realize everything's meaningless, because otherwise you're going to worship false idols, and that's literally one of the commandments that God told you not to do. George, when will you create a money printer? I'm tired of working. You know what? You're gonna. We used to pray for times like this, what's that from? You're gonna pray for times when you had any sort of meaningful work, right? You're tired of working. Oh, you have no idea. Yeah. No, we're just drinking. We're down at the bottom of the barrel. This is literally the bottom of the barrel. Okay. Back to okay. So we didn't actually get a kernel built yesterday. There's a lot more that we can get done with Tenstorrent. I put my critiques a little bit more together. For example, there's this API called create device. So we didn't totally I read through the, no, they're never gonna find us. So here, this is an understanding of the Tenstorrent stack. So TT Metallium is supposed to be their CUDA equivalent. The problem is that it has a C++23 API that's very unstable. So to summarize all of my advice to Tenstorrent, stop focusing on this stuff and focus just on this stuff. If your card is going to find success, it's going to find success in a new domain. You are not going to win by building mid-tier LLM stuff. And this stuff is mid-tier LLM stuff. Every neural network accelerator company puts this on here and thinks that it builds faith, but it really doesn't. Because none of these things are going to work well, and nobody's going to switch off Nvidia for you. But what you can do is you can build a really solid, do what Nvidia did with CUDA. I remember CUDA. I remember first reading the CUDA docs in college. It's 2008. I'm at RIT, and I'm reading this thing, and I'm like, whoa. It was cool. And you do the example, you get it working on the one crappy little Nvidia GPU you have, and you launch a bunch of kernels, and it's slower because all your overhead is just in communicating with the GPU. But it's a cool programming model. Struggling to get an LLM demo to work is never going to is not going to make you the next thing. So I tweeted about this. I summarized my thoughts in Tenstorrent. I summarized my thoughts in the TinyGrad Discord. I hope that there's some people in the Tenstorrent Discord that I hope are not reflective of Tenstorrent as a person. People always people give me shit sometimes. That, there's ego hot stuff back in the day. And I don't know. I ask myself that a lot. Do I have a big ego? I'm not afraid to say I'm better than people, right? But that's just true. If I can beat someone at a head-to-head skill game, there's no point in being fake humble. But then there's also a question of people who have an ego and they go so far with that ego as to lie, as to lie in the face of nature. And you really just got to be humble in the face of nature, right? So it's totally fine. I don't think having an ego means saying that you're better than some people, right? Because you just are. That's just true. Right? And there's some people who are better than you. That's just how it works, right? But that's how that's how you want the world to work, right? I want to live in some commie shit fest where it's everyone's equal. That's terrible. No, there's people you're better at, and there's people that are better than you, and there's got to be people that are better than you, because then what do you have to strive to, right? And it's not a stack rank. It's not one clear hierarchy, but there's got to be people better than you, right? But therefore, if there's people better than you, there's people you're better than. That's not having an ego. Having an ego is the kind of person who you internalize these things as some thing about yourself, and I don't know. It's also confusing. That is why I stream, right? I like that streaming thing. That's kind of true. It's kind of not true. I don't know. Yeah. Today's defo philosophy stream. But no, today is not just a philosophy stream. We're going to try to get TT Medallium, and we're going to build a kernel, because now we can finally think philosophically. I heard something said about if you're living in the hood. The thing about living in the hood, you ever walk through the hood? I was walking around Hong Kong. We walked through this poor neighborhood, and everyone's kind of rich in Hong Kong. It's not real poor, but it's just the cacophony of sound. Oh, there's just constant sound, right? And then you go to rich people's stuff, and it's always so quiet at rich people's stuff. So hopefully we can finally focus on philosophy, because that card isn't screaming in the background. No. They're not really ghettos, but yeah, the poor parts of Hong Kong, they're not scary poor, but they're just loud. All right, we need a meditation session. That sounds good. 3 minutes. I don't think we can do 5.
Find a comfortable position and allow your eyes to blink closed. We'll begin today by taking taking 3 big cleansing breaths. Let's take a nice big inhale through the nose. Side out. Inhale through the nose. One more big inhale. Now bring all your awareness to the crown of your head, allowing all the muscles of the crown of your head to relax. And now, like a warm liquid, allow this relaxation to flow downwards into your forehead, your eyes, your cheeks, and your jaw, completely relaxed, allowing all the muscles of your face and your head to relax. And allow this feeling of relaxation to flow downwards into your shoulders. Feel your shoulders melting down, flowing downwards through your arms, all the way to your fingertips. Feeling both arms completely relaxed. Feel your chest relax, your belly, your hips, and allow this feeling of relaxation to flow down through your legs, to your knees, down to your ankles, all the way to the tips of your toes, feeling both legs completely relaxed. From the crown of your head to the tips of your toes, feeling your whole body completely relaxed. Take a big inhale. Let it out with a sigh. Big inhale. Now let it all go.
All right.
Namaste.
I like this. I don't know if I showed you guys this song. This is what to read. This is how to sleep. This is when to breathe. This is what you're scared of. This is who to hate as of late. This is Orzo. These are war zones. This is your phone. Can you feel the heat? So, let's move. Oh, you guys are hearing those noises. Those noises are harsh. Let's see if we can get that Metalium build system moved in here. So I had my build here. Oh my god, that noise is terrible. Wow, I can't believe you guys were listening to that. So what did we settle on? There's some like boost reflect thing. I saw some criticism that I don't use LLMs nearly enough. Is 4.0 like a good fast LLM? I don't want to go into this debate. Never mind. We're just going to have to settle for bringing reflect in here. I have to like log into Google. Does it have an app? I mean, the other thing about like the LLM thing too is it's the same, I think, impulse that drives people to talk about like, oh, how they like supercharge their workflow with like NeoVim or Cursor or whatever new garbage they're using. What I've noticed is there has been not only no productivity improvements in coding with LLMs, there are now people who Jonathan Blow had an interesting tweet about like why software design got so much worse. And I think it's the same reason college got worse. It's because you expanded the population of people doing it. It used to be just the top 10% of people that would go to college. And then once you expand that to 50%, you didn't make those 50% of people better, you made college worse. And I think the same thing is true about software. I think there's way too many people in the industry. And I think overall they bring the average quality down. I forgot how this relates to my point. But yeah, no, I do think that one thing the LLMs have enabled is there were people who previously didn't understand and they knew they didn't understand. Now they post some crap into an LLM and then post the LLM response like they think they're doing something. And then there's the kind of person, you have to like watch for this kind of person on Twitter, who will say, well, George just doesn't get it. I mean, this is possible. You always have to be open to that possibility. But, I mean, you know, you should look into it. You should seriously consider it. And you should find what the truth is. I think there's too little emphasis on that. I think there's too little emphasis on... This comes back to my point earlier about ego. There is a truth. Or, you know, something like truth can't be racist. Like, in the same way, like, truth can't be egoic. Those are just, there's the truth, and then there's your opinion about that. But those are completely separate things. And I think that maybe the statement, maybe the saying, like, all statements are market manipulation kind of comes to mind. Like, no, I don't live in this like postmodern shit world where that's true. I don't agree with this. Okay. So let's see now if we can follow the TTEL Medallium tutorials. So unfortunately, these tutorials are all broken because this create device API no longer exists. Like the API that we had to use was this mesh device create unit mesh because create device was not there. Update your include path. Probably some way to specify this. How do I specify and include path? Oh. Create, which doesn't take a device ID. Did it lag to re-render an open tab? Yeah, well, it's the finest JavaScript that JavaScript has to offer. Sweet. So this just doesn't build anymore, does it? Okay, seems cannot deduce auto type. Just complaining that's not used. Incomplete type. Oh God! See what? What does that even do? Command Q is not supported on mesh device. Use individual devices instead. Okay. I mean, there's not like a secret way to get create device back, right? Okay, cool. Create device works, something just changed. I don't get it. Why is it so quiet? Because I put the computer in the other room. All right, cool. So that seems to work now. Let's give this a type. iDevice pointer. Get rid of this mesh shit. Get rid of that. Cool. All right, okay. It's looking like this demo's working now. I don't understand it. Host API. Cool. Okay, that seems like a reasonable kernel. Program. What's core? I don't really understand what this does. Data movement config dot processor equals data movement processor RISC-V 0 dot knock dot colon RISC-V 0 default. Is that going to work to build the thing? Okay, I don't actually know if that built the program. Interleaved buffer config. Wow. So I don't really understand logical core 00. I thought logical core 00 wasn't 10.6 core. Can I also fix that so we can copy paste, but I guess not. Why it doesn't listen. See, it's on mouse mode now. I hate this crap. Why doesn't that listen to MRC? Okay, whatever. Alright. Single tile size. Num tiles. DRAM buffer size 2048. All interleaved buffers have the size equal to the page size and entirely contained in the first DRAM bank. All right, so does everyone understand what DRAM and L1 are? The only thing I don't understand is which part of the D1 these are actually in. All right. Where is create random vector of bfloat 16 defined? What? Okay. Sure, that's an API function. Great. My runtime args are in a std vector? Okay. Doesn't work. Invalid narrowing from unsigned long to unsigned int. Well, now you're a valid narrowing. Congratulations. All right, set runtime args. Put the program in the command queue. And then finish the command queue. Right, so that's very similar to like OpenCL. It's a very OpenCL-like API. It's a weird API, I think. I don't understand why you set the runtime args on the program, but okay. Did we change our mind? Not really. My main complaint now is that this API is in some crazy version of C++ and you have to link to all this stuff to make it work. If this API was like a simple C API like CUDA, I'd have a lot more faith in it. Okay, cool. So this did something. Oh, does that have my list of input? That's cool. Let's comment out the right and see if it still passes. Okay, faster. That's pretty good. I think there's some way to enable some debugging so we can see what's actually being built. Okay, it might actually be possible to build a TinyGrad runtime on top of this. I feel like I did this stuff once before. We need to declare some circular buffers to enable data transfer between the reader, compute, and writer engines. TT metal logger level. It's not right. TT metal watcher. Okay, that changes something. Do I need config equals debug? Oh, do I need to rebuild with that? Should just work, right? So. We'll see if we can get that other thing built, the LLMs. What didn't build about this? A bunch of C++ garbage. Deep in the C++ garbage. No member name string in namespace std. Okay, well. What? Oh. Not the right file. Include standard int. Oh, I'm thinking more about the whole ego thing and like what it is that like drives these people to be the way they are. And I kind of think it's ego. And I kind of think it's projection. Like there's a lot of people who have an identity built up. And if something comes in and challenges that identity, it triggers these defense mechanisms. Yeah, no, I think yeah. I went on this date. I'm thinking about like what was wrong with this girl, and I think that a lot of it was, and she's the type who's like this like leftist activist type, and she's so deeply ingrained the story of capitalism that she can't conceive of it not being true. Like the idea that like more money is better. And I think there's a lot of people who cling to stories like that. Cool. It prints debug now. Nice. Alright, well, let's get rid of the watcher and just do debug. Oh, what? So broken? There's some assert that if you do a debug build, it doesn't work. ChatGPT tell me to do here. Edit this file. It works. That works now too. Alright, good. This is the exact kind of debug I was looking for. So you can see here is where it builds the stuff for the risks. I mean, I had this working once before for Blackhole. For a grayscale, I mean. So you can say, like, what's the perf on Tenstorrent compared to a 4090? I mean, this is a dev kit. I would never actually buy this and try to, like, use it for AI stuff. You buy it because you want to struggle with this kind of stuff and you want to play with the new architecture. Like, if you're just trying to straight up, like, use it, a 4090 is way better. I'd say the ego gets you attention. I mean, Silicon Valley is a trash heap. What's come out of Silicon Valley in the last 15 years? Nothing comes from there anymore. The whole thing, these people have convinced themselves that they're important. They pass fake dollars around and like this. I think it's really easy to make two companies really big. And you do this by, you start company A and company B, and they both have contracts with each other and they both pay each other money. Now, both of those companies can book that money as revenue. So company A is paying company B for services, company B is paying company A for services. Both people book that as revenue, and you can do this as much as you want. You can make company A and B arbitrarily large doing this. You can raise based on this revenue, get more money into your pass the buck back and forth system. So this is what a lot of B2B SaaS is. It's just this with extra steps. When you get down to what's actually like being produced, the answer is kind of nothing. And what's happening with Silicon Valley is, so it used to be, sure, you make $1 per user, and the way that you would increase your money that comes in, right? The way that money like comes into Silicon Valley, it comes in through selling the attention of people like Google and Facebook, or hardware sales like Apple. But you eventually get to a point where you saturate the population, and Google and Facebook got there 15 years ago. And then you can't make more money by making a better service, because a better service might attract more people, but you're out of people to attract. You've attracted the whole world. You've flooded the total addressable market. So the only way then to increase the amount of money you're making is to make more money off each person. Now you can say that, okay, well, one way to do this is to expand it to more services and provide more value for that person. But that's generally harder than just figuring out, okay, but we already have this person as a captive audience. How do we just extract more from them? So that's like what the imports are into Silicon Valley. And then internally, there's this whole circle jerk economy. And again, like I say this, and you might have some people from the outside who can listen to this and make some critical arguments about why this isn't true. Okay, these are these things that are actually coming from Silicon Valley, but this isn't the defense you're going to get from people who are there. The defense you're going to get from people there is a very egoic defense. Because if they were to admit that what I was saying was true, their identity would fall apart. Their identity I went back and forth with someone on LinkedIn who, the new YC person, and I'm like, yeah, you can't really, like, you're not gonna, the next Airbnb or Stripe or DoorDash or whatever isn't gonna come from YC. YC and the whole Silicon Valley startup is a completely captured ecosystem. You're playing in their sandbox. And his reply to this is, well, yeah, but you have to play in the sandbox. There's too much risk otherwise. That exactly proves my point. You're completely aware of what this is. But there's some disconnect where if you were to really admit that, there's also not much risk. You can go work at a FANG company and get a FANG salary. Right? There's not risk there either, but you're not really doing something that much different. They've sold you entrepreneurship TM in a box, but that can't be what entrepreneurship is. The minute you put it in a box, you're actually just literally playing in somebody else's sandbox. You work for a company with extra steps. I didn't watch the Johnny Ive video. I just heard it was cringe. I don't know, but I also don't know what comes in and breaks this. Because these people do, at the end of the day, have a lot of power. They have a lot of power through controlling the means of communication. If that YC partner actually said that YC is cooked, yeah, partner. Yeah, someone in YC said, yeah, well, there's too much risk to do this without the Silicon Valley ecosystem. Well, at that point, you're not really starting a company. It's 9 years into the company. How many years can you ship a dev kit? You're talking about Tenstorrent? Huh? I mean, how many years is comma into the company? We're 9 years into the company and we're shipping with pretty much a dev kit. The PMC has too much power. Well, the old PMC things do sort of seem to be shifting away from them. But if you've seen Elon's stuff about the Doge, it's not going to work. Because you can't just go in there and be like, oh, we're going to cut spending. You have to change incentives. If you don't change the incentives of this system, you're going to keep getting the same outcome. The fact that Cursor isn't a YC company? No, I mean, even I was in 2016 and I wouldn't have gone to YC. But also, I don't know why you hold up cursor as some shining example of something. All right. Wow, someone gifted subs while I was gone. We made this with the Lamar Zoko. Took a while. No, sorry, I should have told you. No, I mean Tenstorrent's a real company, right? Do you think I'd be spending time on this if I didn't think Tenstorrent was a real company? Cursor is not. But yeah, there's kind of like this fake economy that all of these things participate in. No, like again, the reason we're here, the reason I'm spending any time on this is because Tenstorrent's a real company and I want them to succeed. This is what a company should be doing. A company should be shipping basically a dev kit. Surely, rationally, one should learn to play the game with these people. Don't make me sing the Pink line. Well, how's it working for Elon? Again, well, no, but is it? You're making an implicit assumption here. You're making, again, almost the capitalist assumption, and it's crazy how completely pervasive this assumption is throughout society. The idea that like more money is better, bigger is better. Jerry Seinfeld has a bit where he talks about, everyone today with their jobs are so obsessed with, how much does that pay? How much money you make? Back in my day, it wasn't like that. It was like, who had the coolest job? All right, and then one guy would show up and he's a firefighter and he'd just win. And you could look at me and be like, that's quaint and old-fashioned, right? And I'm all for conservative beliefs need to stay in the past. I'm a progressive. But Starlink, and we can get to Starlink. And what I think Elon's downfall is going to be. The money is fake. We're in some. There's an amount that people care about money, and I think maybe it's finally starting to recede. But people can care about all sorts of things. There's nothing inherently that makes money worth caring about, especially when that money buys you less and less. But so I think the problem with Starlink is, yes, Elon has succeeded from a very goal-oriented perspective of, oh, look, we got all of these satellites into orbit. But now think it through a little bit more. Who does Starlink end up benefiting? There might be some adjustment period where it's great. Oh, great! Everybody has free internet on the airplanes. This is great. It's fast, but no, I'm not even making like a Randian point as much as making a. Does anybody? Starlink is proprietary. It's undocumented. Like many of Elon's things, these are not open source projects. What Elon has repeatedly not been able to do is build sustainable governance that lasts for a long period of time. His companies are run it's competent, but it's a monarchy. And the monarchy works as long as you have a good king. I think this is one of the reasons that Elon's really into having kids. I think he realizes that he needs heirs to run his companies. And I'm not saying that this is necessarily a bad strategy, but it looks very fundamentally different from the way that we think of Western society and we think of building institutions. We think of building self-perpetuating institutions. I mean, I don't really know how to do this either. It seems like it's an incredibly hard thing to do today. But when I look at things like the Linux Foundation, well, that's interesting. This is the kind of governance. Like Linus Torvalds is a lot closer to the kind of governance that I would want than Elon Musk. Whilst I can say that also while still believing that Elon Musk is very preferable to what we have today. I mean, I largely like the CCP. Like, not ironically, in America, I can say whatever I want. I like the CCP. I think that there's a lot of propaganda about them. I think that they're not. I mean, there's definitely some downsides, but open source foundations being corrupted and tyrannicized, yes, of course, and some of it is. I don't know how well, like, does the Linux Foundation continue without Linus Torvalds? Linus Torvalds, like, his attitude is the exact sort of attitude that I want to see in power. Dictators are always more. A good dictatorship is always more efficient than a democracy. The problem is, a bad dictatorship is much worse than a bad democracy. You're trading off, you're trading off like risk reward. So the fake money problem is much more of a problem in a society that's decentralized than in a society that's more centralized. In a more centralized society, if you see somebody abusing the whole fake money thing, well, you jack mom, right? And by the way, I largely support what they did to Jack Ma. Right? Here's what he was going to do. It was the cardinal sin of what you do not do in China, which is he was going to IPO Alibaba on Western markets. You don't understand. Capital flows into China. Capital does not flow out of China. And whenever I talk about this stuff, it's interesting to see the comments. The comments are usually something along the lines of George has no idea what he's talking about. But they never include a critique. They never include what I get wrong. They use that kind of tactic, and you'll see this tactic in a lot of places. The goal of the tactic is not to it's just to sow FUD, right? It's just to say, well, how could he say that possibly about Jack Ma? That's anti-freedom. But in reality, that person saying that, like, I have this understanding of it. There's definitely people with this understanding of it, but they have this understanding of it. There's so many things that basically look like that. I think we were talking about one of them before, where I brought up the bell curve meme. It's like you think I'm here. All right. I see how you think that, and we can make an argument about whether I'm right. Right? We can make an argument about maybe I am actually grouped in with the retards, maybe, but maybe I'm not. And there are ways to demonstrate that aren't, George doesn't know what he's talking about. Okay. Well, you can look at Singapore and you can ask yourself if you want to live there. I don't think Singapore is a necessarily bad place to live, but it's not where I would choose. All right, let's try to stay on topic. I stayed up late last night. You know what I was doing last night? I played Roller Coaster Tycoon. I've been watching Roller Coaster YouTube, and then like it's just the Roller Coaster YouTube to Roller Coaster Tycoon pipeline. there's only info and debug, it looks like. So somehow I put 0, 0 as a virtual core. No, I'm in San Diego. Okay, so let's think about this, what it would actually take if we wanted to build a TinyGrad backend. There's a ton of complexity. There's a ton of like, I remember how, let's really try to read this. Okay, a 10.6 core. This guide is unfinished. Everything's unfinished. Near memory compute. A 10.6 core operating on its local SRAM achieves silicon peak of what current technology node allows for. Connected into a mesh via 2 NOCs. And each 10.6 core can communicate with any other 10.6 core in the mesh and with off-trip GRAM as well as Ethernet cores. I wonder how explicit this messaging is, or if it can look like just mapped address spaces. One of the things that I didn't understand about how the memory access worked, I thought that you actually had to like pass messages down through the cores, and I'm like, oh, this is such a nightmare to code for, but apparently it's not like that. Apparently every message is just addressed on the NOC. One of the cool things about Tenstorrent is, you can see it also in those architecture docs, they expose stuff that looks a lot more like how chips work. So you can read like the RDNA guide, and you're never going to see them talk about things like NOCs. You're never going to see them talk about things like how the cache is connected to the cores. They'll talk about coherency, but only from like a software level, not a hardware level. So it's cool that Tenstorrent exposes all of this stuff. Enable programmers and compilers to optimize both layout and movement of the data. Data movement is explicit and decoupled from compute. there's no caches, no global crossbars. I mean, this is a very interesting. So like the DSP doesn't have this. GPUs have these memory coalescers. I don't exactly understand what a cost they are. Caches, that is a different. There's not that much of a difference between like an explicitly managed SRAM and a cache, but this one is actually a large architectural difference. So if you think about, if you look at something like RDNA4, here, this is a picture of the die, right? Did I actually have a picture of the die? So if you look here, like these are the L2 caches. There's a large, I guess what they're calling a global crossbar that allows this L2 to be read by any of the compute units. Right? Any of the compute units can access the L2. And Tenstorrent doesn't have this. Tenstorrent doesn't have, the memory is explicitly on some of the cores. So I'm not exactly sure what all the implications of that trade-off are. It's the same guide, or who can? Okay. In 10.6, compute instructions operate on tiles, 32 by 32 matrix of scalars. Don't know how I feel about that. I don't really understand what that means. Operating on coarse chunks of data allows for the use of a simple single-threaded RISC-V processor to dispatch these instructions. So this is to the 10.6 core. Think bare metal core is not thread. Every RISC-V processor runs single-threaded, and core-to-thread mapping is 1 by 1. Yeah, so they don't have a warp scheduler either, which, again, neither does the Qualcomm DSP. This is where they lose me. Like, why is it 5 cores? So, when you look at something like the, I just wouldn't do this with 5 cores. That seems so strange to me. Where do I have extra? Again, no, where's Excel? TPU here. So the Google TPU uses this VLIW interface. It's like a very long instruction word. It's all in order, and it can control all of the parts of the core with this big instruction. The Tenstorrent, it just strikes me as so weird that they're different RISC-V cores. I'm sure that's not the right choice. Like, some of their story makes so much sense. I've come around on memory on the edge. Like that stuff's very sensible. But why this core doesn't look more like either a DSP style core? But I guess you don't want a DSP style core because, yeah, I don't know. But like, it's interesting how Hexagon deals with this. Hexagon will deal with this by using VLIW packets of instructions. I feel like that's the best trade-off I've seen. But like, pack, compute, unpack, this is not that generic. If you use VLIW, you need a good compiler team. I mean, yeah. I think that Hexagon's the best trade-off. So if you look at Hexagon assembly code, they have... What? None of this is Hexagon assembly code. They use... we can find it. It's called nnlib. Yeah. So yeah, these are the implementations of things for the Qualcomm DSP. I'm so happy I found this, by the way. This saved me a lot of time. So like, yeah, this is a conv2d. They use these 4 instructions inside the curly braces run at the same time. And then the manual goes into how, like which resources you can use, what combinations of instructions you can put in these things. But so it's like a packet of instructions. And I really like this approach. Again, you could imagine the Tenstorrent thing looking like this instead of like 5 independent cores, which is super hard to reason about. You say like, oh, well, but these cores are going to run in lockstep. And like, that's great if you're coding in cycle counting assembly. But if you're coding in C, you don't know how the compiler is going to optimize things. You're going to have things that break when you compile with like O0 and O2. And to be fair, I haven't written Tenstorrent kernels, so maybe they have some nice way of dealing with this. But just from a surface perspective, it's hard for me to think about how that works. Versus something like this, where it's very clear to me. Okay, well, this is doing, these are multiply accumulate instructions. This is a memory fetch, and this is a cache preload. Cool. That's all in a packet. Like, I would love to see, instead of these Tensix cores, Hexagon cores. Imagine a grid of Qualcomm DSP cores. No, but like you're like, oh, they need a software abstraction that makes this simple. But that's so against the whole rest of Tenstorrent. All of this stuff is, we're going to expose to you like you're going to implement your own global crossbar, which is cool. Hexagon instructions have shape N5. Tenstorrent has 5N. Yeah, that's a way of thinking about it. The other one's so much easier for me to reason about. Behind the scenes, a compute kernel becomes unpack, math, and pack kernels. Yeah, I mean, I see what it's doing. Okay, let's work on the high performance. Let's look at the high performance matrix multiplication example. Learn MLIR at 7 steps. To do. Write it. I'm too much of a software guy to understand the plight of a hardware person. I mean, I think let's talk about questions like that. So something that I like to do when I meet somebody is I like to ask them a whole bunch of knowledge questions. Right? To ask them do you know what memory coalescing is? And some people get offended by this, and you shouldn't, because what I'm basically doing, I'm not trying this isn't again, lose your fucking ego. This is not an ego thing. I'm trying to see do you understand? Because I really wish people would do this to me. I'm too much of a software guy to understand the plight of a hardware person. To be honest, I don't know what I don't know. So, do I know what hardware people know? I can take some guesses. I've coded in Verilog before. I'm familiar with what the programming paradigm is for it. I've never taped out a chip. I've written a simple RISC-V core in Verilog. I understand pipelining on a conceptual level. I've never actually implemented these things. I'm not sure if there's a big gap of things I don't understand. In thinking in my work here at TinyGrad, I've spent a lot of time thinking about what the actual hardware implementations of these things are. So I think I understand most of the, understanding what a global crossbar is. I understand what that is now. From a conceptual perspective. From a, here are the transistors that go into implementing a global crossbar, I could try to think about it. But I don't understand. I don't know if there's some conceptual thing that I'm missing there. And what I find with two kinds of people, and I think it comes down to, again, a security of the person kind of thing. People who are insecure will tell me, oh, there's lots of stuff you don't know. Okay, that didn't help me. Then people who are actually very secure in their knowledge would be well, and actually a few conversations with Jim Keller, very, very much, George, yeah, okay, you can think that you want that, but here are the problems you're going to run into. And I love when people do that. I love when people say, okay, yes, I understand 5 years ago when I thought that was a good idea. And then I looked into it a whole bunch. And here's pretty much the exact evolution that your thoughts are going to go through. And they explain to me, they first show me that they understand how I'm thinking. And then they tell me the next thing I'm going to think. And I'm like, damn, okay, you understand. I respect that so much, and I believe you. And I try to do this to people too. I try my best whenever I'm capable of doing that. Okay, I see why you think that. I thought that once. But here's what you're gonna run into. And one Jim Kellerism, and I like how Tenstorrent focuses on this, is so much of power is spent in data movement. It's not the compute itself. It's bad. Tons of waste in data movement. And everything's statically schedulable. There shouldn't be this waste in data movement, but it doesn't mean that it's easy to figure out how to statically schedule things. He came down and visited Comma a few times. We talked about this stuff before he was at Tenstorrent. Can I tell him the software is bad? I have. Again. Well, you can say that. You can say there should be an all hands on Monday, but again, you'll watch responses to criticism. And responses to criticism usually fall in like two kinds of buckets. There's people who get defensive, and these people should just be like discounted. Right? These people should just be like, oh, yeah. I mean, it's. But no, I don't think it's necessarily going to be that. I think it's more, well, okay. I mean, we could put effort into cleaning up the MLIR documentation and API. We could write a simple C API. We could make it more portable. But what exactly is this going to get us? And that's a good conversation to have. A lot of people are, George, comma, why don't you do any advertising? You should be better about doing customer support. You should really make sure. And when these people are making these sort of criticisms, they're operating under the wrong model of what my objectives are. My objectives are not to increase device sales. That's a secondary objective. Increasing device sales is a good thing, but only if fundamentally it comes from making the software and hardware better. The goal at the end of the day is to make the individual box better. I want a comma that is better. Right? Now, if that leads to device sales, that's a great way to measure how much better it is. But it's not a metric you can optimize for. This is Goodhart's law. So I would say that, I think Tenstorrent software is bad, and I would change the following things. And it could be like, well, George, yeah, but those are things that you're optimizing for. And that's a place where, I mean, you can't, this is like the is-ought problem of moral philosophy, right? You can definitely talk about is. You could talk about if you make these decisions, it will lead to this outcome. And two people can have a debate on those things, but there is fundamentally a truth. Whereas, actually, our goal is to just increase the number of red balloons in the world. You can't tell someone that's a bad goal. You can tell someone that buying green balloons isn't going to increase the red balloons, right? That's an is. That's not an ought. What other objective can they have? What, sales of the you think their objective is sales of the cards? I don't think it's that. Oh, then making good software and hardware? Well, define good. I don't know. And to be fair, I haven't I'm going to go back to TinyGrad work tomorrow. This is not my job. I haven't. One response to my criticism of the software is, George, you just haven't spent enough time with it. And that may be fair. That may not be fair. I don't know. You spend a good amount of time with it, right? Yeah. Again, I think that this is echoed by some people who've spent a good amount of time with it. If Blackwell works well with Torch, it's never going to work well with Torch. This just isn't going to work. Yeah, and that's an is statement. From what I've seen of this approach, it's just not going to ever be good with Torch. Well, at least we want to look at their MLIR stuff. So we might not have found what their Torch stuff is. So that the TTNN thing is, not only is that isn't even Torch, right? That's interop with Torch. That's not actual using Torch code. So they have this TT-MLIR thing. I don't know if this lets me. Is there a Tenstorrent Torch thing that I can build a version of Torch that lets me actually type torch rand A equals torch rand B equals torch rand A at B, and that mapmals them? PyTorch 2.0 TTNN. Okay, so this does exist. Allow PyTorch code to run on Tenstorrent hardware. Oh, do I have to use torch compile? TT torch. Okay, so this is, it only works for torch compile. It doesn't work for torch. Which is the more up-to-date one? Should I use PyTorch 2 or should I use... I mean, I guess this is like always a hard thing to do, but okay, so like what's TT Forge? Is this the one I want? Okay. So we have TT Forge, TT Torch, and PyTorch 2.0 TTNN. Which one do I want? Yeah. Oh, and then don't forget TT MLIR. Try ChatGPT. I bought a Tenstorrent Blackhole card, and I'm trying to run PyTorch models on it. What's the latest, most up-to-date open source repo that I should be using in order to do this? I also have to do it with compile. It's begging to have bugs. I mean, yeah, people will probably like move this direction. Yeah, I mean, torch compile is kind of a, you know. The other one's hard to, yeah. Like, I want to be able to take any PyTorch repo off the internet and make it work, and most PyTorch repos don't use torch compile. And I'm not sure I see them moving there. This gives TensorFlow vibes. Okay. TT Torch. But what about that other one? Also, another thing about using LLMs, George, why do you still use Google? Why don't you just always use LLMs? LLMs are wrong so often, but you don't realize they're wrong. These things are optimized with super powerful RL to give you an answer that you're happy with. Not necessarily. I think there was a distinction. I like this distinction that went around on Twitter. Some people train their models on helpful versus harmful, and they fine-tune them to make them more helpful. This is awful, right? You don't want to work with a model like this. You want a model that's tuned for truth versus falsehood. All right, this is CMake crap. Oh God. It's calling Python 3.10. Okay. Oh, did I recursive clone? Ugh. Find a torch. Do I have to clone torch? Let's take the normal and get submodule thing, and I remember how to do this. I mean, this probably works on Ubuntu. I'll bring up Avonics models. Oh, stuff's so painful. Requires a PyTorch installation that ships with their ABI. Yeah. So I'm gonna have to build Torch. I mean, it's good to understand like how this stuff's being built. Right? Read the distraction comment. Do they have it in their Docker? What? What?
George, you don't understand. You just shouldn't be using this. You just should use the thing that's already set up and works for you. Yeah, and this is why your life sucks, okay? This is why you don't understand anything going on around you, you know? Because, but no, there's a tiny bit of friction. No, you have to just, the struggle is the fucking point. It's not about the destination. It's about the journey. That's the amount of people. I don't even understand. How do these people go on vacation? You know, after a week, you're just going to be right back where you started. And then they come up with the most asinine justifications. Yes, but I made memories. What? So what if you could just download the memories? Would that be the same as your vacation? It's a completely incoherent philosophy. Oh, we have a TT Torch Docker. All right, sweet. Was I raised Catholic? I wasn't raised religious, but I gotta like Docker load that shit. Is that it? No, it doesn't work. What's the Medallium Docker?
Is that a Catholic philosophy? Do Protestants and Jews do things just for the destination? Docker pull.
Huh. I don't think that's gonna work though. Yeah, I mean it would automatically pull, I think. I just don't think that's the right path. What's GHCR? Is it a GitHub thing? I don't think it's sudo docker pull. GitHub container registry, interesting. Tiny transformers PyTorch. So the Medallium one is not going to work for... Oh, you gave a broken link. Okay. Try this one. I'll just change IRD to base. Yeah, all right. Cool.
Is this all just some kind of like proxy religious war? How do we make the Catholics win? If that's the Catholic way of thinking, how do we win? Pancakes look nasty. Should we get a crab? Should we order a crab fried rice? All right. Let's try this. No module named TT Torch. Do I need to activate some VMs? Gotta download a few Dockers and patch the firmware for noise. Yeah, it's normal. Normal shit, man. Normal shit. You know, we wrestle like normal in the Kazakhstan. You know, just like that. Right. So like, what? Inside the container. You're a liar, ChatGPT. I think I saw it something else in here. No, it is TT Torch. We don't have release Dockers for TT Forge yet. Okay, well, can I build it in here then? I have to make it from source. Cool. Yeah, no, we're having a great time. We're having a great time here. Everyone's having a good time? Having a good time? Building. Let's just, maybe it's best of times. Yo, like we could live in such a nice world if like people would just get over whatever this thing is. I don't, this like zero sum mentality, this belief that somehow you can win by taking from others. You can't. I'm not saying this in a like moral sense. I'm saying this in I'm the greediest motherfucker in the world. I want everything. I want my own planet. I want my own galaxy, man. I want to take over the universe. But you're not going to be able to do that by taking from other people. Because other people don't have a universe or a galaxy for you to take. You can't take that from them because they don't have it. Like, and we could get it, but you're not going to be able to take that from other people. And I am shocked that this mentality exists and like seems to be so prevalent. And maybe it's just because the things people want are pathetic. Well, I want a house and he has a house. Okay, you want a house? Oh. You can never win a zero-sum game.
You can have it all. My empire of dirt. Oh, cool, it finished. Mm-hmm. All right, which of these instructions did I not follow? This one? We were zero sum for most of history. Yeah, I mean, I guess that's kind of true. I don't know. I mean, this stuff starts to get creepy to think about, but what is it? What's there? One line in one of these songs. Yeah. One day we'll be holding hands instead of grudges. We'll eliminate our territorial circuits and know what love is. One day we'll be holding hands instead of M16s. Till then, every human being is controlled by the fight. The problem... Someone's going to try to do this. Someone soon is going to try to do this. And I'm not afraid of AI. I'm afraid of the person who falls for this ideology. Because it's so difficult. You can listen to me talk about this and you can be like, this is just all bullshit. George is just playing a zero-sum game to try to help himself. Did I not? Okay, do we miss a step? Like, I'm not sure which of these steps I actually have to do in the Docker. Could not find Python 3.
No, there is Python 3. That's not the problem. Like, this whole approach just builds on so much cruft, and we're compiling gigabytes and gigabytes of cruft. You don't need any of this. Jonathan Blow tweeted, it's like, at least things have gotten better in the last 4 years, since some people are like talking about the problem with the software. I don't exactly know why this happens. Like, you're just like, oh, I'll just implement my one little piece of the cruft. And then I'm building the MLIR, the TT. Writing software is too G-loaded. That's why most of it is bad. I think that's kind of true. I wonder. Well, yesterday was talking about how, like, well, no, but I love that bad abstraction, because that bad abstraction is the reason I have a job. We need to kick 90% of people out of fucking computers. Like, if we kicked 90% of people out of software, this would all get so much better. This used to be constrained. This used to be constrained by the computer has 8 kilobytes of RAM. So you're going to put a lot of thought into each variable you're putting in those 8 kilobytes of RAM, because the computer has 8 kilobytes. So there was kind of a natural function. Did I not create a VM for the TT-MLIR toolchain? Did I miss one of these? Okay, here's the TT. Oh, it's not found. The base image doesn't have LLVM pre-built. This one does. Okay, but do I still have to build all the other shit? Okay. Am I just bad at this? I'm kind of confused by how a lot of people deal with this software, like the things that look like this. It's got to be a huge struggle for everyone, right? It can't be this hard unless it's designed to be used by no one. Well, but it's not designed to be. It's not designed to be used by no one. It is just yeah, I mean, that's something I like to do. Like, I think a lot of people, again, it comes from like a place of insecurity, where people are like insecure to be like, honestly, I have no idea what the fuck that is. Right? Like, a lot of people won't say that, because a lot of people, feel insecure or feel dumb, or like, if I'm dumb, there's got to be some bar here, right? Like, you can be like, well, George, you're dumb. You just don't know how this works. And, like, you can say that. I don't know, but I feel, like, pretty secure in my abilities, where it's kind of like, at that point, who is this for? All right.
All right, so yeah, I mean, you know, I'm the guy who'll tell you that the emperor has no clothes. And you know what? Maybe I'm just, dude, he's wearing a skin suit. You're a fucking moron. And you know what? Maybe I am, but whatever. Alright, so like, which of these do I have to follow? I don't know, let's just follow them all. But we can't sudo in the Docker because I'm already root. So we're gonna bitch about how there's no sudo. Okay. Apt update. Alright, I'm following every instruction. Apt upgrade. Apt install Clang 17. Apt install Ninja build. Apt remove CMake Y. Pip install CMake upgrade. CMake version. CMake V. 11. Okay, that looks good. All right, now, no, we can't sudo. Install that. Skip the toolchain step, okay? So I don't need to do this. All right, so let's just see if it already exists. All right, it already exists. Okay, that's good, that's good. Now, source env activate. Yeah, I struggle with this like everyone. I know, but no, actually, I don't struggle with stuff like this in my real life. Because in my real life, I don't participate in this. Like, everything that looks like this, I'm just like, I'm buying a different card, I'm using a different piece of software. I really don't participate in things that look like this. The problem is there's no other good hardware? Wait, what do you mean? Buy a 9070 XT. Okay? This card is half the price of a Tenstorrent Blackhole and has similar performance. So you're going to get 16 gigs of RAM. Yeah. Instead of 32. You're going to get more memory bandwidth. You're going to get more teraflops of FP16. Same system interface, same external power. The cooling's actually good. I have one of these in the room. Similar clock speeds. How many CUs does this have? So 64 CUs, 120 tensor cores. Like, unless you have a particular affinity for this kind of architecture, everything about buying this card for AI is going to be a better experience. No, sans Nvidia would literally buy this AMD card. I have one connected to my Mac right now that I can just use. George spends half these streams just showing off TinyGrad. Oh, yeah, that's what I work on, you know? So like here, we can just... We need to fix that. Oh no, I had to use sudo. Oh, this was so painful. Okay. So like we're running right now on the 9070 XT. You want to see it? There it is. It's plugged into a USB port of my MacBook. The only dependency that you need is TinyGrad, and this is building things with ROCm, but you can also use LLVM with AMD LLVM equals 1. No, but software is hard. How is this possible? Like, again, the USB thing is like crazy beyond belief. But if you just take one of these cards and stick it in your computer, just like I did the Tenstorrent, don't install the AMD driver, just use TinyGrad, you'll have a phenomenal experience.
And if anything goes wrong, it's this many lines of Python. Right? You don't have too much to look through if anything goes wrong. Literally, the only external dependency is LLVM. And brew install LLVM 19. LLVM 20 has a bug. There's actually we found a bug in LLVM. Not like in a way we're using it. There's actually a bug in LLVM. Brew install LLVM 19. Right? You can also just install the LLVM 19 package on literally whatever you want. TinyGrad, pip install TinyGrad. No AMD driver, no ROCm, no bullshit. 13,500 lines of Python. Again, many of them not even on code paths you're going to hit, right? Like your ops DSP this is actually perfect. This is perfectly abstracted away. You'll never have to think about it. I feel like there's this mentality also, it's like software has to be bad. All other software is this way. Like, no, it's not. TinyGrad's legitimately not like this. But George, TinyGrad is 10x slower on LLMs. I showed you guys yesterday. It's not 10x slower. What are you talking about? Okay, oh my god, I have to press beam equals 2. Like, okay, I need to put in one flag. What the hell's that crap? Okay, actually, no, I think it's accessing the wrong model. So this is the 1B one. We'll see how it does. Oh, camera blocking, sorry. I don't know why the 8B one didn't work. You give that a second, we'll see how it does. So this is running a 1B model, and the parameter gigabytes per second is 334 gigabytes per second, okay? So that's like this is running a 1B model at batch size 1. So when you're running an LLM at batch size 1, you are limited by your memory bandwidth. So the memory bandwidth of my M3 Max is 400 gigabytes per second. So this is 83% of the theoretical max. I don't want to hear, TinyGrad is 10x slower. You actually, did you write beam equals 2? Even without beam equals 2, that's 83% of the theoretical max, and you'll get that on almost all LLMs. Our mixture of expert stuff is not as good. Our mixture of expert stuff is more like 40%, but still not 10x. Okay, like, I don't know. There's some weird guy hating in the Discord about this. It's like there are legitimate critiques of TinyGrad, but that isn't one of them. And then I don't even know what you do about that. What you do about this, these people really just don't know what they don't know. You can say that it's slow, but why is it slow? Go ahead and torch stuff right. Why did 8B not work? Why did it it must have downloaded something weird. It's stale. How do I have a flag to ignore? This probably won't happen on your computer. Always good to fix a little bug. But you can go try that command right now on your computer and see if it works. I have an idea that it's only broken for me because one of these things didn't download correctly. Yeah, those just don't look like the right size. Computing hashes of big things is slow too. Those just look corrupt. I don't know why they got moved though. It must have gotten like disconnected. Yeah. See, like, look, it's downloading 4 gigs now. To be fair, yeah, that's like shitty. That's shittiness of TinyGrad, but like it's hopefully like it's straightforward to understand what I did there and what happened. It was probably busy downloading the thing, and somehow the connection died in such a way. Well, maybe this has already been fixed, right? Because this is the fix you're going to want here. If the length doesn't match what you said the length should be. So I bet you someone already fixed this. My cache is just stale. What do we got? Yeah, George, but I can get 100 tokens per second using ggguff Q4 on my. Yeah, but dude, that doesn't matter, right? That's not the same model. You can also like play with quantization if you want here too, but like you're just in some rabbit hole of. You're not running. I don't know. Maybe there's just also like no demand for local AI. I mean, I don't use this shit. I use ChatGPT, right? I use ChatGPT just like everybody else. Like eventually they'll make it shitty and you'll be like, and shitification is going to be harder this time. But again, okay, so 21.3 tokens per second. There's 21.3 tokens per second on an 8B model at float 16 quantization. So we multiply by 2. That's 340 gigabytes per second, okay? With batch size 1, because you have to read every parameter in the model every time for a dense LLM. You've got to name this shit noob lessons. The theoretical maximum on this computer is 400. So we're what of the theoretical max? We're 85% of the theoretical max. Felt like when I was a kid in the schoolyard talking about cars. I knew nothing and had many opinions about engines. Yeah. No, am I fighting just a losing, like, is this just all a losing battle? Is this done yet? Oh, well, good. We've completed Torch MLIR. That's great. That's great. It's my optimization objective. Oh, God. Like, this is the problem. The minute there's an optimization objective, don't worry. The ad people and the Google, that's already like, you just.
I'm going to get a sign that just says Goodhart's Law, and I'm going to tap the sign, okay? When a metric becomes a target, it ceases to be a good measure. When a measure becomes a target, it ceases to be a good measure. Right? So no, you can't have an optimization objective. Right? You gotta make fun of people by using a nerd voice. What's your optimization objective? Right? Because that's how do you get around this otherwise? I think it's like shame and mockery. Yeah, change the world. That sounds good, right? That sounds good. Yeah, let's change the world. You know, Hitler changed the world, man. Not all changing the world is good, right? You ever seen Sam Hyde's TED Talk? It's pretty good. Brah. One second, I'll check something. Great. No fat LTO objects. Good thing. Good thing. I don't like fat people either. Yeah, I'm with you. I can feel that. All right. CMake install build. All right. Run a basic test to verify. We compiled tttorch in the Docker. If I like exit this Docker, is there any way to like get this back? I don't know how Docker works, or do I gotta like build more? Well, okay. So does this work? Let's try to compile a single convolution. tttorch has no attribute compile. Okay, well I think that's just the LLM hallucination. At least now we're importing tttorch. Okay. Some list of like, does this example work? All right, great. We added 2 times 2. No, what I want is the stuff that does like, can I like run a model from like the way people actually use Torch like this? Yeah, is this gonna work? Okay. So I have a model. Well, let's actually load the pre-trained one. No, operator torch vision NMS doesn't exist. Okay. Okay, we'll look at the supported. Oh, you've had this one. Oh, how do I fix it? All right, here's some models, okay? I'm gonna try MobileNet V2. Okay, test ResNet 18, okay, here. All right, all right. Oh no, I don't think that's doing anything. I think we have to run it with PyTest. God. All right, we eventually got it done. Okay, so this supposedly works. All right, let's get the model. All right, that worked, that worked. All right, convert it to bfloat 16. Oh, I have to set up this complicated compiler config op. What? So where's that simple add one? What if I use that same mentality on the here? Okay. So import the Torch Dynamo backend, compile the model. That was fast, suspiciously fast. All right, let's get some inputs. I don't know why you have to take your inputs to bfloat 16, and then let's try it. Oh, well, there's an MLIR error and verification failed. Op10's torch must be a... Again, I did normal fucking shit, okay? I didn't do anything weird here, did I? You're using Arch. I'm in Docker. TT torch. An error occurred during compilation. Did I do something stupid? I think the... Yeah. I don't know. I don't know if it's... I think the disconnect for like... I feel that a lot of people who work on this stuff are not ML researchers. So I worked at Comma for 7 years. Most of that time I was basically an ML researcher. The amount that you're like, nobody will tolerate this. This is why Nvidia is winning so hard. Let's do a test. Let's try something. No, we'll have to figure out how to install the driver. Do you think it's worth it to try to do the same test with AMD? Okay, install AMD GPU driver Arch Linux. No, I'm not sure that's the real... All right, so first let's just try the PyTorch thing. So I'm not in a Docker now. We're just going to try this in raw Arch Linux. I have an AMD GPU in this computer. So we'll try Linux. We'll try RockM. We're going to just do it like the dumbest way. I think this isn't going to work. Oh, well, I should have to uninstall Torch. AMD GPU DKMS. That seems like what I want. And there's a chance we just don't need it. I'm going to try the exact same test on AMD, by the way. I know, so I don't know. This AMD driver might just work. The built-in one. Okay, cool. All right. Let's do that same test that we were doing on AMD. Import Torch. Import Torch Vision. Download a model. Convert it to bfloat 16. Compile the model. Oh, do I care about that? Oh, I should probably say model equals model.CUDA. That's downloading it to the AMD GPU now. Let's torch compile the model. Let's make an input. Put that on CUDA too. Sick. AMD's come a long way. I mean, all I did was follow like the simple instructions here. Let's make sure we're actually like in AMD land. Actually, I have a simpler one. I have one in TinyGrad. So I have a torch gem test. Let me just try it. Cool. That's pretty good. So Torch is getting 113 gigaflops on my 70. I mean, that was actually incredibly impressive.
I used the built-in AMD GPU driver, the one that shipped with Arch. I didn't have to build anything else. All I had to do was this one pip install command. And it worked. That might even be better than CUDA. I didn't have to install ROCm. I didn't have to do anything. Wow. Good work, AMD. So this is what I mean. Like, these things are not the same. You heard yesterday when I was praising AMD. None of this shit worked when I started. 2 years ago, there was nothing like this. Installing AMD was a nightmare. You'd constantly get driver crashes. Now it's just using the upstream driver and the latest kernel, pip install ROCm 6.3. Yeah, AMD's actually been making great progress. I'm waiting for this to be priced in too. I put $250,000 in AMD. I'm telling you guys. No, like, they still have problems. Like, you see what the semi-analysis guy tweeted yesterday. Like, they have problems. They have bugs in their compiler. We'll find them. Forget flex attention. Like, yeah, I'm sure that shit doesn't work. Whatever. And maybe it works, maybe it doesn't work. But my point is, I followed the absolute basics of downloading a ResNet from TorchHub, Torch compiling it, and running it, and I got an output. Sorry. And this thing is like, oh, sorry, you can't import Torch Vision because it doesn't have Torch Vision NMs. And this is after I installed some Docker and spent 20 minutes building stuff and picking the wrong Docker 2 times. Right? Like okay, I just want everyone to understand. There's no defense for this. Right? It's bad. You can say it's getting better, but is the path that you're taking actually going to yield you this result? I strongly doubt it. And here's why. Here's why AMD was able to do this. I explained it to you yesterday. AMD was able to do this because they don't have a custom backend. AMD took every CUDA package and cloned it and wrote an exact clone of it, changed the N's to R's, and now, yeah, it works as well as Nvidia does. I mean, probably not. There's probably a whole set of edge cases where Nvidia is a lot better, but at least the installation process looks like Nvidia, and it's because the two accelerators are basically identical. No, I don't think Tenstorrent is on a track to improve the way AMD did. AMD followed a path that was, again, watch my old videos. You can see all my complaints about AMD. My complaints with AMD were that they didn't test shit and that they didn't have CI. I mean, I guess I was misunderstanding what AMD's goal was. I thought AMD wanted to leapfrog Nvidia. They don't. AMD is very happy getting 5 to 10% of Nvidia's market share and being the fourth option. I mean, it's slightly better than CPU, am I right? And it is. Yeah, it's the 7th software attack at Tenstorrent. Without fundamental culture change, it won't be fixed. I mean, something at AMD's culture changed. AMD sent me 2 boxes. Right? And don't try to tell me I'm holding it wrong. How long has Tenstorrent existed? 9 years. So do we want to go back to writing like kernels? Let's hold me accountable. Let's actually go back to my initial
The software is called RISC-V. It's open source and it supposedly works with PyTorch. So I've tried 3 years in the last couple of years to build it, and every time it didn't build out of the box. I struggled to fix it, got it built, and it either seg-faulted or returned the wrong answer. Not what happened this time. They fixed it. 2023. Oh, wow. It's actually almost 2 years exactly. And we, of course, succeeded at this goal. I mean, to be fair, let's not go overboard with the praise here. This isn't training. Let's see if training works, actually. This is the test one I like. And just so you guys know, there isn't like secretly an AMD GPU in here. Secretly an Nvidia GPU in here. It's slow. I'm going to compare it to I need my tinybox config. I haven't done anything yet. This is 5090. Yeah, well, I mean, it's a little better. Yeah, I don't know what's happening there. It's trying. Let's give it more time. Is it spinning the CPU? It's spinning the CPU, so it's doing something. Oh no, what if it's not on CUDA? What if it's actually trying to train on the CPU? No, then it'll be using all the cores. Yeah, so that, I mean, that's pretty sick. Oh, I have something I wanted to test too. We got the new TinyGrad should support 5090s with the NV backend. So let's see. I'll show you the TinyGrad equivalent of that CFAR trainer. It's slow in the PyTorch version by a good margin. Oh, it worked! Okay. It was compiling. It's compiling all the kernels using Triton. Cool. So this works with the NV backend now. So this is the TinyGrad re-implementation of HLB CFAR. "19 seconds. Okay, so it's this 7900 XTX is 4x slower than a 5090. Which, yeah, it's about a quarter of the price. Yo, you know what? I'm half tempted to get rid of the discount on the red boxes. Like, this is actually really usable. What is NV backend? Yeah, it's Nvidia without CUDA. I mean, it's still using the it's still using CUDA to compile, but it's not using it to run. The whole runtime is in TinyGrad. And you don't even have to use it to compile from CUDA code. TinyGrad's happy to output PTX. The problem is it's hard to get from PTX to SAS. There's nothing really open source that does this. SAS is undocumented. So yeah, this is a place where TinyGrad's maybe 10x slower. Yeah, 93.7. What did that one get to? 94. That one got to 93.5. Okay. You want to see if we can make it faster? See how fast that goes. All right, now it's going to take the same 60 seconds or 5 minutes to compile that PyTorch does. So again, the only reason NVIDIA, AMD can do this is because they have the NVIDIA crib sheet. So when you actually read this code, it's all CUDA everywhere. Which is, actually thinking about it, kind of a smart decision. So AMD doesn't make you type .rockm. When you install ROCm Torch, it's just .CUDA. AMD also is like, again, the reason we shill for them hard is they're the exact kind of player you want to disrupt a monopoly. The person who's actually okay with getting 5-10% market share and just keeping the front player on their toes, great for the world. Well, AMD is great for the world. What, because like Lisa Sue and Jensen are cousins? This shit's ridiculous. Oh, you can hear it a little bit. By the way, the tiny box that's doing this is in the room with us. You can see it aggressively compiling CUDA kernels and calling the CUDA compiler many times. Oh, the Luminal one? I think they have interesting ideas. I think that they should not re-implement a front end and should use TinyGrads. I think they should focus on just the compiler aspect of it. But like, you know, everyone's not invented here, so whatever, no one's gonna listen. But you know, they have some cool stuff in the compiler. They're using eGraphs. Like their compiler infrastructure looks more advanced than TinyGrad's. I don't know if it's more robust. I also didn't see any benchmarks from them. So like, we focused a lot on things like upcasting and filling out the registers and tensor cores and stuff. I'm not sure Luminal focused on that stuff, but they do have a nicer way of talking about kernel fusions than we do. Someday we're gonna rewrite the TinyGrad backend in Rust. Like, I can see a world where tensor.py stays Python, but then everything below it kind of becomes Rust. Eventually. Once we've solidified all the algorithms and the progress to only make is in, like, search speed and heuristics and optimization, then that's a good time to become Rust. But, you know, we still have probably several years of algorithmic iterations. In general, when you're looking at, like, speed in programs, your biggest gains are always algorithmic. Your biggest gains are, what is it? Like, it's an Elon thing, like, don't optimize what shouldn't exist. So, you know, you move to Rust and you're optimizing things that shouldn't exist. First, make them not exist. Oh, I could use C++ 26? New headers. What's in C++? You know, it's not even that C++ itself is a bad language. My biggest criticism of C++ is that it's just too big. It's way too big of a language. Everybody's C++ looks so different. Python has this philosophy. It's like there should be one way of doing things. All right, so now it's like twice as fast. Still pretty awful. This shuffling thing is only bad because we're still doing it on the CPU. That's really slow. Huh? Why did that take 14 seconds? I don't know. This shuffling comes from a time before we had this stuff working. I gotta just go through and update this example. But that step time isn't that bad. I think that step time is within, like, I think Torch is something like 20 milliseconds. Okay. We tried all of this stuff. We're building this kernel.
Hey, George.
Hey. Hi. Should we work through there? Any idea how the index type ends up becoming a float? I don't know. You'll have to look at what their decomp is, but it's exciting that they have a decomp for it. Torch has this great file called decompositions that break complex torch down into primitive torch ops, and that's like perfect for TinyGrad because we'll do all the fusions anyway. So yeah, any decompositions you can, if you can enable a decomposition and it causes an error, we should look into it. So we're getting pretty close with our Onyx front end. So we have, TinyGrad has 2 front ends. The Onyx one is getting to the point where we can move it in. So right now it's not in release. You have to go here. You have to install TinyGrad from the repo if you want this. But yeah, the Onyx front end is getting close to complete. So I think our op coverage is, I mean, it's hard to say whether you're better than Onyx runtime or not. Maybe the thing to look at is what % of models you run correctly. And we're working on a big CI test to do this. I think it's pretty close to complete now, which is cool. And it's pretty simple. These implement the Onyx ops in TinyGrad, so you can just load an Onyx model in. So that one's going to get moved to the main repo. And then there's the Torch. It's called Torch backend, but it's a backend for Torch and a front end for TinyGrad. It puts Torch here and TinyGrad here. This is what I showed off yesterday. So this one still has you can just read the code and you can tell that it's not nearly as high quality as the Onyx port yet, but we'll get there. ORT has so many ops. Yeah, I mean, they're not that hard to implement though. What we really try to do is make as many of them possible. Look, I mean, that's just like, look at how beautiful that code is. That just shows like code like that's like, people, George, why would you write code like that? Why don't you write a terrible softmax with a big if statement? And no, like, come on. All right, look at the difference. Right? It's so obvious to. I want to write the code that looks like the pseudocode. I want to write the code that most concisely expresses the idea. Yeah, so this is our Onyx front end. I think we do support a good number of the contrib ops. All the ones that are used. Like maybe attention as a contrib op. Oh, this needs to be cleaned up to use. Wait, what? How come this isn't using scale.product attention? It can be cleaned up. But it also doesn't really matter if you use scale.product attention, because again, these things are all going to be optimized at a lower level anyway. This is just a waste of lines. A waste of lines, and not just a waste of lines, but a place where you're more likely to get bugs. Quantization. These need to use the actual optimizers too. We need some basic implementations of the optimizers. I have a PR up about fused optimizers. I want to move to fused optimizers. What is Tiny Atom? Oh, okay, that is actually calling the. That's good. And then these are just the ones that pass through as tensor ops. Let's read this matmul single core.py. mean, it's implementing a matmul. I don't know if it's necessarily a lot of lines, but what's crazier is that it's actually not even the matmul kernel. This is just the dispatcher for the matmul. These are the matmul kernels. Oh, why does set mouse equal that in the thing not work? Stop detecting the mouse. So everything's done by tiles. Not here. What's the tile size? I mean, so this is their like their tensor core. Like, why is there a leaky rel? Why is there a ReLU tile? Why is ReLU in operation? This is an example of SFPI code. So is this where the ReLU tiles are implemented, or is there actual stuff? Why is nothing updated for Blackhole too? Yeah, I mean, actually, we can just check out the repo. Let's check out the... Is this their main one, mvmol? Okay. So it looks like their tensor core size is 16, 16, 8, which is fine. That's a normal tensor core size. But it looks like it's in place. So you have this concept of in place and like, again, I watched the Qualcomm Hot Chips presentations. I think they talk some of the best about this. Like, so if you think of something like a systolic array, like a systolic array is going to shift out, and then where those things actually go, well, does it, or are you keeping the accumulator local, and then you shift out the accumulator later? Is the accumulator a normal register or not? And if you go back to like
old school 8-bit machines, right? You used to have this register. I don't know if you guys ever coded for like the PIC microprocessor. I think even like the 8051 was like this. You have an accumulator register. And that accumulator register is special. Right? You can do things, maybe you have like an accumulator, an X and a Y register. And you can move the accumulator to X and Y, but your output was only into the accumulator. When GPUs have tensor cores, the GPU tensor cores can largely output anywhere. Also, like the AMX is in place. So Tenstorrent is in place. I mean, in place is always just harder to use, but it may have power advantages because you might have to do less data movement. Yeah. I don't feel this is gonna. I don't know if this is what's being used under the hood in TTNN. But I don't think that code that looks like this is going to work. I think that you've built a data flow machine, but you're trying to work on it like it's a computer. You're trying to, like, you're writing sequential C code like this, and this code's not auto-generated. This code should be auto-generated. And parameterizable. What if 8-bank? What if it's not 8-bank? What if I want to change my tile size? But then, like, also these things kind of should not be parameters. They should be recompiled and compiled in every time. Is the same mammal? Get compile time argval. Why is this C16? What is that? Oh, the identifier of the output circular buffer. Wait for tiles, do the map on the tiles, pop the tiles, continue, grab a tile packet, push it. Let's look at something like the LU tile and try to figure out where it's implemented. Like, is the LU tile implemented in something, or is this in hardware? All right, LLK math, LTWise, unary. So this is the LLK API. Okay, that's fine. Yeah. I mean, this is also like just not how I would do this. This stuff can't be how many, if you want to add a new activation function to Tenstorrent, how many layers would I have to change? I don't think this LLK stuff is the way to do it. Oh God, there's stuff about the derivative here. This stuff needs to all be auto-generated. It's when I see stuff like this, it's sad because you think of all the time that went into this, and it should have just been computers. So, I mean, when you look at the Tenstorrent stuff, where's that picture of their stack? No, they have a better picture of the stack somewhere. I don't think TT Forge is still real. You know that picture I'm looking for? Where'd it go? No. This? Yeah, this one. Okay. So, like, you wouldn't even be able to implement TinyGrad at this layer, because this isn't the right abstraction. Things that look like this are not the right. Like, you're gonna write a kernel for everything? This should all be auto-generated by your graph compiler. When you think about it, like, one of the ways to judge this is to say, yeah, if I come up with a new, if I'm a researcher and I come up with some new activation function, right? You see, like, it's an LU, but then it becomes a ReLU at 3. How much, in order to get performance, so you can always implement that at some very high level in terms of torch tensors and taking round trips to memory. But if I want to actually get performance out of that, how many layers do I have to change? Right? So we'll call it the FELU, and I'd have to create FELU.h in here with like initializations. And then at a higher level, I'd have to create a tile init. I'd have to pray this all compiles and link this back to my PyTorch, and I'd have to like expose a new. This just can't work. What am I gonna add FELU to stable HLO? Like, I think that these compiler things are relying on some lower level being able to do fusion. Because if you don't have some lower level that's able to do fusion, you're going to basically be taking trips to memory. Maybe you can chain the tiles without trips to memory, but at least it's going to be trips to SRAM, and you're not going to be able to do it in your registers.
So like for all the things that Tenstorrent gets right about data flow, they then write C-kernel, SFPU, LU, and all that potential performance improvement is just dropped on the floor. It should cost you no more time to compute a double LU. You want to see how to do it in TinyGrad? So let's go no opt equals 1, CPU equals 1, debug equals 4. Okay, so I'm going to create a random tensor, 10 by 10. So that's random. We can say it, just random. All right, so now I'm going to do a double LU on it, right? And then convert that to NumPy. Let's support LU. Oh, no, I'm just tired. Okay, cool. So you can see that this double LU is being computed in a single function. So we're not taking 2 trips to memory in order to compute this. We're staying in registers. There's only one loop that counts to 100. And the LU logic here is duplicated, and that's automatically done by the TinyGrad compiler. When you have an approach like this, this is not possible. Right? What you want to do is this, but there's no way to do that without going in and manually editing the code. You need something that can auto-generate at this level if you want to get performance and you want to allow research flexibility, which is a new card. It's what you need. Don't listen to me. I've only been thinking about this problem for the last 5 years. Think about it every day. And this is the best hope I have at pushing back. One thing that I've kind of just accepted axiomatically, because like if it's not true, I'm really just lost and have no idea what to do, is that complex software stacks privilege large organizations, and simple software stacks prefer individuals. You're always going to have imbalances of power, but you can decide how big you want your imbalance of power to be. There's some things that it's not unrolling the loops. It's about whether you're taking an extra trip to memory or not. It's about keeping your data as local as possible while you're doing element-wise operations on it. So like you'll see, you can go even further with this. Like I can also do .mul2 here, which is going to multiply it by 2 in between the 2 LUs. And this is the code that was automatically generated. And you can see here that there's a times 2 put in there. Right? The times 2 also got distributed somehow, so there's a times 2 there. But you can see that the end result is, well, actually, it shouldn't exactly be times 2 because it was after the LU, but we can move it and put it, so we'll really get a perfect times 2 if we put it there. I'll put a mul1 in there, and you'll watch it just go away. But yeah, you can see that just the output is then modified with this times 2, and that's C code that's being compiled by Clang and run. And then I don't know if you guys are interested, but instead of setting CPU equal 1, you could just set metal equal to 1, and this will all just work for metal. I'll do it because actually the reason this CPU is kind of crazy is because we don't have an exp function in the. There's no exp function in a CPU. So like you can see that the kernel in metal is a lot simpler. Oh, I just did X, but I didn't do LU. But yeah, so that's the LU kernel in metal. It's a lot simpler. Actually, you can read this and you can see, I don't know, maybe they do both have to be gated, but there might be some like optimization possible there. You can do that as a rewrite rule. All right, you guys want to go further? So I can just do this as like a Python-C import from TinyGrad, import tensor.rand, and 44.contiguous.lu .numpy. Alright, so if you want to see what the LU looks like, I'm going to just run this with viz equals 1. And actually, let's just clean up this stuff so we don't have to empty. So we'll just have the one kernel. I don't have to mess with the other ones. So that's the LU there. You can watch it like go and turn into code. So I'll rerun it here with a second LU. Look, now it has 2 LUs.
I don't know how you see things like this. I don't know how you watch. I hope people at Tenstorrent watch the stream, and I don't know how you watch this stream and then go back to writing C kernel SFPU LU.
And then also, I don't know how this stuff's being called, but can you be running an LU at the same time you're running a matmul? This is the beauty of the Google TPU compiler. Like, they really are incredible at doing all this stuff, which there's no fusion possible here. There's no op fusion possible. You're like, oh, well, you op fuse it at the tile level. Yeah, I don't know. To my point, maybe they don't care. I mean, okay, don't care. Don't win. If you guys want to see the difference when you run this with a CPU, so you'll see that the kernel starts out pretty much the same, but then in this final rewrite, exp2 is not a valid op on the CPU, so we expand exp2 to a Taylor expansion so that it can actually run. Yeah, you have to have a great compiler if you want any chance of running well in VLIW. Yes.
So, I mean, I do think this ends with us making chips after a really long period. Like, we're not going to make chips next year. I can be excited about it and push for it, but there's so many things still to be dealt with at like a high-level algorithmic thing that needs to be fully understood and fully made simple. Then when we build our hardware, a bunch of things are going to be true. Our first chip is going to run every model TinyGrad runs, which is like everything. Right? Try to find a model TinyGrad doesn't run. Again, we support most of Onyx, like actually working, not it's going to give you some error on some weird op. It actually like just works. But George, I found this one thing that doesn't work. Okay, I bet you it's a 2-line change to fix it. It's not 1.0 yet, like we'll get there. But the question is not like, does it work perfectly out of the box? The question is, when you're missing the felu activation function, how many lines is it to add? Do you think they can win without having developers make useful stuff on top? Maybe they just want good hardware and to get acquired? No, it's not going to work. Anyone who's playing for an acquisition, I don't know. Like, you've already just lost in my mind. You've already just decided we can't win, right? The first step to wanting to win is, first step to winning is wanting to win. If you don't want to win, SIMT is very different than TPU. Does the software need to support both before to bring hardware? It's not that different. SIMT mostly just gets you nice abstractions that you wish you had in TPU, but we are going to, if we do not have torch levels of performance on Nvidia, we are not ready to tape out our own hardware. So yeah, I mean, when we do make our hardware and when the chip ships, it's going to work out of the box for every TinyGrad model, and it's going to work out of the box on every computer because there's not even going to be a kernel driver. It's going to be user space Python, M-mapping, PCIe, or if there is a kernel driver, it's going to be a 100-line kernel driver that just sets permissions up correctly. We probably will have to do. I don't think that set cap on Python is actually a shippable solution. We'll ship a very simple DKMS package for every common Linux distribution, and this DKMS package will use APIs in the kernel that have been there for 17 versions. So yeah, no, we will probably. Well, actually, I don't know. I think there is a way through VFIO, if you have the IOMMU enabled, to expose things to user space in a safe way. Part of the problem with just straight up exposing things to user space, and I wonder if, I think Tenstorrent has the IOMMU, but if you just expose something to, if you expose like something with a DMA engine to user space without, I don't know, I haven't gone too deep into the security model of GPUs, but if you have a DMA engine, if something's sitting on the PCIe bus with no IOMMU, and you have a DMA engine that can hit physical pages of memory, I mean, that's just, you can get from user to kernel. IOMMUs are, like, fine. I don't know. I mean, I don't like them. I think that there's, like, you look at all, like, the mitigations for, like, Spectre and Meltdown, and there's kind of almost two use cases of computers, right? There's computers where you care about the user being in a sandbox, and computers where you just don't. Like, you don't care if everything just has kernel. So if you don't care where everything just has kernel, like, yeah, you don't want IOMMUs and stuff. But, yeah. So, I don't know, maybe the other interesting thing that I wanted to look at for Tenstorrent, and I think we found it yesterday. So one of the things that I really like, that I think they did a good job of, is not, so if you read the RDNA 3 manual, where's the picture I'm looking for? So they have this thing called the ultra-threaded dispatch processor. It's unclear exactly what this even is. I also think that this might be where the bug is on RDNA 3, because you hit weird race conditions sometime, and I don't really think they're in the firmware. There's some like weird configuration registers for this thing, but this just does not have to exist. You have very flexible cores that are capable of directing their own, that should be capable of directing their own, like of deciding what to run. The cores should be popping off the queue themselves. You shouldn't have something that looks like an ultra-threaded dispatch processor. So I think that this is a mistake in GPU architecture, and it's nice to see it fixed in Tenstorrent. So let's look at what their replacement is. Yeah, multi-tenant VM is again, this is what I mean. Like, there's a whole different. Sure, if you're running some, I'm giving people like a tiny VPS to host their WordPress blog on, sure, yeah, this stuff matters. But if you're running a compute training job across 10,000 computers, you don't care about, why would I want an IOMMU? I control those 10,000 computers. I guess you can think about the scale of jobs. Right, the scale of jobs for computers, and there's some jobs that need like 1/100th of a computer, and there's some jobs that need 10,000 computers. And the ones that are 10,000 computers, obviously you don't need an IOMMU. But the ones that are 1/100th of a computer, yeah, like stuff like that matters.
This should all just be like, make these UOMs in the way. Meditation. Oh yeah, we were looking for the so I think this is like the base code that runs. I'm not sure which one does the maybe the BRISC. Are there any docs on the firmware? I should just talk. There's also two things they call firmware. Oh, power management. All right, we're looking for something that like reads from a mailbox. And then like, okay, this one's gonna trigger the trisks.
Yeah, you watch like people hitting like rowhammer from JavaScript, and you're like, that's hopeless. I don't know. I think there'll always be a cat and mouse game. I'm not sure this is ever going to be like solved one way. I mean, that's a deep question about cryptography, right? Is asymmetric cryptography possible? I don't know. It's so cool how like math looks like a Mandelbrot set where you continue to get complexity as you dive down. Okay, that's good. Wait, what? There's a dispatcher core? Work through the entire launch of a single kernel. Is there a dispatcher core off of the 10.6 processor, or do the 10.6 processors launch their own kernel?
Each command queue is serviced. Oh, Otherwise idle Ethernet tile. All right, so maybe that's what eRISC is. Or NC-RISC. Sama, I want faster O3. I will pay you money for it. Maybe you should run it on a Tenstorrent chip. Cerebus really is the right architecture for that, though. That is like I do think Cerebus has an interesting niche carved out.
that I think, and Grok just looks like bad. It's not. Grok has no real advantages over just using Nvidia without the DRAM, as far as I know. But Cerebus actually has hopefully much lower costs to move data across that wafer. Cerebus is a very interesting company. So they might be able to do something like build faster O3. But now you don't even know. You don't even know how many of these things are hitting microservices in the back end. Right? This is hitting the web search service microservice. And once you've adopted a microservice architecture, well, you're just begging for things to be slow. E. I mean, this is actually less. This still kind of does look like a GPU with respect to like that code running the Ethernet tile is similar to like the mech on AMD GPUs. Toggles the go done bits, but so this actually, what? Copy kernel text into each tile's L1? Oh, but this must be done with a broadcast. The NOC does have like cool broadcasting stuff. So this thing broadcasts, that makes sense. Yeah. Yeah, you can even like, I believe, map the broadcast stuff on the that's another like really cool thing that GPUs lack. GPUs do not have a good way for cores to access other cores' memory, and then they like the command processors have some amount of granularity with how I schedule things, but this whole story in GPUs is very muddy. You probably can use them like this, but just most people don't. I think that like some of the DeepSeek stuff was pushing Nvidia to do it. They've been moving in this direction of like long running kernels, but I don't even know the whole story of like, okay, so I dispatch a kernel to a few cores. Can I somehow kill just those cores? I don't know. We'll get there.
eRISC is embedded RISC. Does it control the fan? When we ask ChatGPT where the fan is controlled. But how do I view that with DeepWiki? Is it that? That's pretty good. DeepWiki's pretty good. You know, another thing, I do use LLMs a lot more in my real life than Google. I don't know how you guys feel about this like new paradigm of the stream. Just kind of like watching me use LLMs. Wait, what? Tenstorrent's not open. It's not open source. It's open source. Really? No, I don't believe this. I like how I don't have to log into this too. Really?
Still running on the user kernel RISC-V. So I mean, like, LLMs will just casually lie to you and people will just accept that as truth. Like, is it lying there or is it lying there? Honestly, I don't know. Google lies less. I mean, fortunately, we haven't descended into a total LLM shithole yet. We will. But you can still usually believe that some text you're going to find on Google was human written. And like, humans lie, but usually when stuff's wrong that's human written, it's either for one of two reasons. It's either it used to be true and it's not true anymore, which is very common in documentation for stuff, or two, it's some kind of like motivated reasoning, right? Like the human's trying to tell you something, like, you know, whenever you read, I'm sure you could go to like Papa John's website and it will tell you it's the best pizza in North America. And that's like obviously a lie. Papa John's is disgusting, but that's just because someone's trying to convince you of something. LLMs just casually lie because they have no real awareness of their own confidence. And like, why would they? It's an autocomplete. And they'll get better at this. They'll get better at this once they're sufficiently punished for lying. We'll get better at lying. All right. Be right back, and then I think we're going to wrap up this stream. I don't know what you want me to do and go further. All right, so I know you guys like when I use Vim for this. Advice to Tenstorrent. Okay, if you want to get acquired / become scam IP licensing co. I can't help you. If you want to win AI compute, read on. All right, so let's start there. This is your 7th stack. Please, bro, one more stack. This stack will be good. I promise, bro. Please, bro, please, one more. One more. Make it all back. One trade. Bro, please, one more. Make it all back one trade. You know that make it all back one trade energy? Yeah, make it all back one trade type beat. You can't build a castle on a shit swamp. Yeah. You can't build a castle on a shit swamp. That as long as you still have things that look like SFPU LU as a LLK, LLK is the wrong approach. Okay? Yeah. Tenstorrent advantage is in more programmability with respect to GPUs. Hardware shapes model arch. The hardware of the world today shapes the kind of models that we run. If you don't expose that programmability, you are guaranteed to lose. Now, what do I mean by expose that programmability? You can make an argument, but it's all open source. Yeah, okay. I love to throw this argument in people's face all the time. I love to say this when someone's like, oh, I have a Mahindra Scorpio and I want to use it with comma.ai, and I'm like, the code's open source, bro. Go figure it out. And you can always like throw that in people's faces, but in reality, you're gonna get what you like. There's like if you've maintained enough open source projects in your life, you realize that there's the kind of things contributors are going to do and the kind of things contributors are not going to do. Contributors will often, if they're hitting a bug, some percent of people, maybe 1 in 10 people who hits a bug with your library, is going to put in the effort to upstream a fix for that bug. That person's probably a very good engineer, and that person realizes that if we can upstream the fix from the bug, this is something that I don't have to maintain. And this is why, like, I don't think that you necessarily need GPL to have successful open source ecosystems. It's very advantageous for a company to upstream something, because now especially if you upstream something with good tests, because now the maintainers of that open source project will maintain your use case practically. So you might get bug fixes from good engineers. You might get features. There's a kind of people out there who just like, they want to write some feature. Oh, I'm going to add some feature to some open source thing. Some of them do that because they want to. Some of them do that because it's fun. The quality of these contributions is usually less. There are some good people who do features too. There are some people who get like nerd sniped by a feature. These ones are usually very high quality. The people who are just like they see the problem and they're just like drawn to it and they got to contribute. But what you're not going to get is refactors. No open source people are going to build an alternative stack for Tenstorrent. Now, you're like, George, but you built an alternative stack for AMD. Yeah, and AMD is the right choice to do that on. An alternative stack for AMD looks like Nvidia, but is more open source. The other advantage to AMD over Nvidia is Nvidia's code's actually very good. Us targeting AMD, it's like targeting Nvidia, but it might actually be useful to somebody. I mean, the real thing that TinyGrad is doing is, speed on AMD is great, we can beat AMD's shit, but no, the holy grail is beating Nvidia. The holy grail is beating Nvidia on their own hardware. And then at that point, you're ready to make your own hardware. You might get some contributor, like just the scope of this project is too large to have somebody come in and fix things like SFPI_LU. And if you don't see SFPI_LU, SFPI_LU is a problem. If you don't see that as a problem, I mean, it's like you have to rethink how you're doing this whole thing, because the choice made in SFPI_LU propagates up your entire shit stack. Right? It propagates up all the way to, are you managing to tie the PyTorch LU through stable HLO, through MLIR, through TTNN, through TT Metallium, all the way down to LLK? Like, are you passing that through seamlessly, 5-6 layers of abstraction? This isn't the way to do this. So, if you want a data flow graph compiler, build a data flow graph compiler. This is not 6 layers of abstraction. It's 3. Okay? You have 3 basic layers of abstraction. You have 1, which is your front end, right? Your front end can be PyTorch, can be Onyx, can be Tensor.py and TinyGrad, right? You have your compiler and you have your runtime. Runtime includes, runtime driver, right? It's 3 layers of abstraction. MLIR, stable HLO, TTNN, LLK. None of this shit should exist. You got to do this. But it's hard. Yeah, I know it's hard. But you're never going to win the other way. The other way is guaranteed to lose. This way you might win. And again, if you want to get acquired or become a scam IP licensing company, I can't help you. But if you want to win AI compute, you're going to have to build this. And you're not going to be able to do this with TTNN, TT Torch, TT Torch _ NN 2.0, TT Forge. Just use one more Docker image, bro. Just use this Docker image. Come on, man. Come on, this one's good. Come on. Like, this doesn't work, okay? And this is very distinct from how AMD succeeded. I mean, they haven't succeeded yet, but AMD has come a long way by copying Nvidia exactly. AMD didn't use this stuff. They just copied Nvidia. And they got AMD support into Triton. And the reason that they get this luxury, and Tenstorrent does not, is that AMD and Nvidia are pretty much the same chip. You look at the new Tensor cores on RDNA 4, they are exact ripoffs of the Nvidia Tensor cores. Right? When you're building a chip that's basically an exact copy of the chip, great, you can take that approach. Tenstorrent can't. Because again, Tenstorrent's advantage is in more programmability with respect to GPUs. Hardware ships model arch. You aren't going to get better deals on tapeouts IP than Nvidia AMD. You need some advantage. Yeah, and like mid-tier LLMs is not gonna work. Okay, so and only 2 you have to build. All right. So now let's talk about where things are. Let's talk about 3. All right, start with 3. The driver's fine. That the stub driver in the kernel, totally fine. Leave it completely alone. The next layer is where you end up in a befuddled mess. So there's this thing called TT metal. Okay, here's TT metal. TT metal is not TT metal. TT metal is TT metal underscore. And then it has this thing called TTNN in here as well, which has like IPython notebook tutorials in it. And no, this is the wrong. These are the wrong abstraction layers. Right. The runtime should just be a runtime, right? I better never see mention of an LU. Like, an LU is a neural network op invented by some grad student in 2013. Why is this in your runtime for your hardware? CUDA came out. CUDA doesn't have LU. Maybe they added LU as a very high layer of abstraction to CUDA, but there sure as hell ain't an LU in PTX. Right. Make the runtime expose hardware in a application agnostic way. This is not easy, but you have to do it. Okay? This is not what TT Metalium is. As long as LLK sits under TT Metalium, you aren't doing this. As long as something that mentions LU is in your runtime, you aren't doing this. Okay, now for 2. So TinyGrad is this, but you don't have to use it. I mean, I'm like MLIR, LLVM is probably fine. I don't exactly know to the level that they are flexible. They're written in C++. I'm less familiar with them, but this is okay. Now, LU still should not be here. This should be, should deal with memory placement. This should deal with ops scheduling. This should deal with kernel fusion. Not LU. Right? Now for 1. Okay? X.LU needs to have same perf as, I'll get the one from TinyGrad. Okay? If it doesn't, you messed up. Once, only once it does, are you ready to write LU? Hint. Right? For how to write LU. Hint is not a hint. It's the actual code. There's no getting out of doing the hard work. There's no getting out of compilation, dispatch, queuing, etc. CUDA is a simple C API for this. I advise doing the same. This is not easy, but importing 6 packages of cruft doesn't. Abstraction layers of cruft doesn't fix that. What? Okay. What happened to the black hole card? I put it in the other room. I put it in the other galaxy. Where's my TT Tiny? We'll push it here. Ah, no. Great. If I improve Tenstorrent as I did AMD, I mean, it's very hard to prove ever about the AMD thing that I was in any way a but-for cause. Like,
AMD, so here's a fact. AMD clearly improved in the last 2 years. AMD went from unusable garbage that was hard to install, that was crashing my system, to we actually ran HLBC 410 and it just worked. It took a while to compile, but it just worked. So something clearly improved AMD in 2 years. Was it me? Probably not. I don't know. I mean, this comes to like any kind of historical attribution, like great man, causes and forces. I don't know. So, I can't take credit for that. The same way as if Tenstorrent improves things in the next 2 years, it's not because of me, right? Like, it's not... I don't know. I don't know if I do anything at all. Like, I don't really... But again, I don't really do this with, like, outcomes in mind. I do this because it's like, shit, man, what else am I going to do, you know? What else are you going to do to keep the boredom away? Well, so, you keep the demons away by like feeling like you have a little purpose in life. You wake up, you have a little purpose. So, I mean, yeah, but like I don't know. They knew it was bad. It's hard to say, but so there's my advice to Tenstorrent. No, I mean, look, also, let's not give them too much praise. They still have a long way to go. But the copy Nvidia strategy has actually seemed to work out for them. They made it work. And I don't know, maybe they like knew this all along. It kind of worked, right? All right. First chip will be bad. I mean, yeah, the first chip will be bad, but there's ways it'll be bad and there's ways it won't be bad. We'll build it on FPGAs first. I have the whole roadmap in my head. It just, unfortunately, it's like going to take a really long time. And like, I go back to work tomorrow and what am I doing at work tomorrow? Well, I got to figure out I got to deal with the fact that you can't put views in the kernel because you can't invert views into movement ops. So I'm just going to cache what movement ops created the views. But then there's a bunch of subtle edge cases there. Yeah. So yeah, no, it'll be bad and understandable. I don't know. I also don't know like the I would never tape out a $40 million chip unless like the software was done. But that's just me, and maybe that's like why I lose at this. So, am I gonna do from the transistor before making the FPGA chip? No, I'm never actually gonna do from the transistor. I realized that I used to believe that education was possible, and now I kind of just don't. Will Triton be the new standard to writing kernels? Yeah, I mean, there's definitely some interesting things about Triton, and there's some things that it gets right. I think that Facebook's chip is targeting Triton, which is quite smart. Like, they're just making something that's going to have a Triton thing out of the box. And also realizing that, like, Facebook's targeting it too gives you faith for the long-term supportability of Triton. It's a shame that Facebook doesn't want to sell their accelerator. I think that they should, but it's not why I hate C++. And there's way worse languages than C++ too. My main complaint is that Python has there's one way to do it philosophy. C++ has there's 10 ways to do it. 2 of them are wrong, 3 of them are okay, 4 of them are good, and then there's one that's great, but you'll never figure it out because you're not Bjorn Stroustrap. Mojo is doing better than you give credit. I'm not
I mean, I've tried to use Mojo. It's not all open source. They have a lot of similar ideas to us. I'll wait till it's fully open source and then I'll go through Mojo. But yeah, no, I mean, look, they have a lot of similar ideas. Like I said, this isn't self-driving cars where everyone was idiots, right? Self-driving cars was just a room chock full of idiots clamoring for who could be the bigger idiot. The machine learning compiler space is like smart people with some technical disagreements and may the best compiler win. Like, now we have a Mojo is so fucking bad, unfortunately. Like, I don't know. I think that there's a reason it hasn't taken over yet. I think that it has trade-offs, in the same way TinyGrad has trade-offs.
We'll allow Mojo's doing better than you just so we don't discriminate here.
Shared memory parallelism to Gale. I don't know if this stuff matters that much. Who is Mojo? The new Julia Lang. That's good. That's good. No, such a smart person would go for Swift for ML. I don't know. To remember Ghost Autonomy? No, guys, they're the serious comma. Oh, man. No, that Founders Fund partner who invested in Ghost Autonomy, he actually had a quote, and I tried to find it, where he's like, they're the serious comma. Yeah, serious about raising 10x more money than comma and returning 0 to the investors. What clowns. They copied all our rhetoric. What complete clowns. This is what I mean. Like, self-driving cars was a room full of idiots. Like, I'm so happy to be in the ML compiler space. You know, what's that XKCD? 2 papers, nobody found out. No, physics thrown out of room. Before exposed as phony by major. All right, let's bring out the big gun. Founders Fund is usually good. Founders Fund's usually good. For the most part, I like Founders Fund. I just think that, like, they didn't like my valuation originally for comma. They did not like my 3 on 20 million. So we went with A16Z. And that's the truth. I pitched 2 VCs. I pitched A16Z and Founders Fund. Founders Fund didn't like. They thought I was asking for too much. And I'm like, okay. X or AI. This is like a... Oh, I feel like I've seen this before. I don't know. Oh, imposter. There we go. That got it. Ah, yes, this one. So, I mean, this is thing about working in the ML compiler space is it's actually pretty easy to tell if somebody's a clown or not. Like, you can tell pretty quickly. The self-driving car space, for some reason, just entertained all these people who, like, didn't know anything about anything, but, like, you know, just like, well, so yeah, we're going to write the software, and it's going to drive the cars, and we're going to use LiDAR. And it's going to, like, have you seen a LiDAR? It can just see everything, man. But what about being able to process it? Well, yeah, we'll hire, like, some software engineering guys, and they'll write the code to process it. I want to focus on the branding, and I want to focus on making sure that this is an inclusive experience where we can really make a car that's inclusive to every, like, this was a real thing that somebody spent money on. Let's make half the seats face the wrong way and design the shittiest bus you've ever... This is a real thing that billions of dollars was spent on. I can't get over the level of stupidity of these people. Like, I look here. I'm sitting here criticizing like Tenstorrent, like, you know, parts of Tenstorrent stack. I don't know, you can argue trade-offs, maybe, George, you know, yeah, that'd be great, but this is going to get us to market faster, blah, 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 blah. Like, you can make arguments. You could imagine a smart person justifying all of Tenstorrent's decision. I could imagine sitting down with a smart person and, like, the end of 2 hours, be like, I might not totally agree with you, but I respect your perspective, and I see how you're going to, like, do it that way. That's actually, like, sensible. Like you went through, like, a... You know, okay, you did this, I think this, but okay, like we can, or maybe I'd even be convinced. Like, I'm not even so close-minded to think, this is just utterly moronic bullshit. Who let these people in the room? Well, you see, half the seats are going to face backwards. Because you know what I love? Accelerating while I'm facing backwards. You get lurched forward in your seat like this. Oh, it's a great experience. And the other thing I love is riding in cars with strangers. Man, it's so great. Don't you just love when you sit down and there's another person who's a stranger in the same car as you? Isn't that just a lovely experience? We're gonna, like, the level, this is wokeism level of moron. Like, and then, like, the wokeism people. Like, wokeism's a whole other thing where it's like, no, you are just so factually incorrect and so blinded by ideology. So I can't believe this, right? And this company is bankrupt. This company cost GM $8 billion and, you know, good riddance, right? Like, the level of... Those are real people who sat down for that advertisement. Like, GM hired people to sit there. And, like nobody, I don't know if the photographer was in the room. He's like, this shit's the future of transportation? This shit? You just can't. And self-driving cars was so full of idiots like this, right? Zooks, let's make a car that's, like, totally symmetrical, dude. That's, like, groovy, man, because we all know that, like, cars don't, like, clearly mostly travel in one direction. No, like, this car will be able to, like, go the same way backwards and forwards, man. We've really optimized the shit out of that 10 seconds of pulling out of your driveway. But, like, what about when you're on the highway and, like, you know, it's really nice to have, like, a front and back shaped differently? Yeah, man, but no. Have you thought about this? It's going to be, like, 4, like, wheel motors. We're going to put motors in the wheels, and you're going to be able to, like, but what about, like, unsprung weight on your tires? And, like, it's actually much better to just have one motor and then make your tire as light as possible so that the suspension's easier to build. No, man, no, you're not understanding my vision, okay? Okay, you don't understand my vision. It's gonna be symmetrical, man.
It's I don't know. I don't know. Like, there's no adults in the room. There's clearly no adults in the room. Yeah, no, these people already went on an ayahuasca trip and shot their brains and made this. And, like, this is all funny if it wasn't costing the world billions of dollars. I just can't get over this. Right. Burning. That's what I mean. So, bringing this back on topic, my advice to Tenstorrent: if you want to get acquired and become a Scam IP licensing co, and you just want to like pack the halls with developers, oh, look at all these things we got going on. Check out my number of repos, man. We got a lot of repos. That's a lot of code. You know how many K-locks that is, man? That's a lot of K-locks. If you're optimizing for K-locks, but I don't think Tenstorrent's like that. I think that it's just hard, and I mean, I find myself doing this all the time. Everybody finds himself doing this. When there's a hard part of the problem, instead of owning up to the hard part of the problem, you're just like, well, yeah, but let me do this other non-whatever idea first. That's like a Todd quote, right? Why would you just you want to see us just doing everything right and self-driving? Look at Tesla, right? Like, this isn't even hard. No, but Elon's a Nazi. I saw him go like this. Well, now you've seen me go like this too. Go ahead, post that on TikTok with the caption "George Hotz is a Nazi" and see if that shit sticks. I really want to dive into someone's mind who thinks that. It's kind of like, do they think that he did the secret hand signal to salute the secret Nazis who live in an underground bunker? So they dead, man. Some of them are in Argentina. You can call him Bernie. You missed him. I do it again now. One time only. Don't worry. The secret Nazis in the bunkers got the message, man. Reminds me of the Dean scream. Yeah, they chilling with Helen Keller's down there too. No shit. Who? Amelia Earhart, not Helen Keller. She was fake. Amelia Earhart. All right. One thing about $3 billion for windsurf. I don't even know what it is. Whose money was it? Who did it go to? What kind of circle economy is this? I think we didn't do enough meditation this morning. Too keyed up for this. I thought about the cruise origin. Somalia. I lost that debate. I don't think I did well in the Yudkowsky debate either. I'm not that good at debates. I don't know. Maybe I could practice with some LLMs. Get better. TinyGrad Financial, how are we doing financially as a company? Or do you want us to pivot to high frequency trading? I mean, we have a lot of GPUs. Should we just pivot to high frequency trading, guys? It's a zero-sum game, and it sucks the wealth out of society, but we could get rich. Think about it. Oh, I like what you're thinking there. What do you say about that part? The we could get rich part? Oh, I like that part. Inverse DeepSeek. That's right. Let's just, OpenAI should just pull the inverse DeepSeek. Just do high frequency trading. Sorry, O5 is not released. We use it for high frequency trading. Yeah. No, I don't know.
The Yet debate's like painful for me to watch. Like I really tried to practice for it, and someone described my tactic as like gish galloping. I'd never heard this term before, but I'm like, wow, they're totally right. I don't know. I'm not the best at, like, sometimes I'm trying to express an idea and I think it's coherent in my head, but I don't really know how to turn it into words. But maybe that just means it was never coherent in my head to begin with. I don't know. Frequency trading exists in this room. I think you assume other people know exactly what you mean. Yeah, because I don't know what they don't know. It's easier for me when, like, I could ask them questions, but... Yeah. Wow, let's work on this. Like,
All right. Thank you for watching today's stream, everybody. I want to see a beautiful C runtime. A graph compiler with a great dialect, but you have to, if self-LU doesn't have the same performance as this, you're doing something wrong. And this is true to everybody who's writing any kind of ML compiler, right? Yeah, it needs to have the same perf as that. Well,
good. I'm glad I convinced somebody.
Host somebody. Well, let's see if is Lana Deluxe is Lana Deluxe streaming today. Let's see who's streaming right now. No Lana Deluxe. Jonathan Blow, no streaming. No, wow. Gemini plays Pokemon doesn't have a lot of. Ooh, we could watch Claude play Pokemon. Claude has more views. Should we raid Claude plays Pokemon? Let's see how it's doing. Is it playing a normal Pokemon? Pokemon Red and Blue. All right, sweet. All right, Claude 4. All right. Can I raid this one? Oh, okay. So I have to paste in my own. Yeah, don't kill people. I think that's hopefully everyone knows. That used to be my sign off, but all right. Go watch Claude plays Pokemon. Thank you for watching today's stream. I appreciate all of you. Look, I just want you to think about your life and think about ways in your life that you're playing zero-sum games. And if you could even take one little step to play a little bit less of a zero-sum game, it makes the world a little bit of a better place. And if everybody just woke up every day and made the world a little bit better, then we would live in a better world. And I will never lose hope, because I watched this movie once. It's called Galaxy Quest. And you know what they say in Galaxy Quest? Never give up, never surrender. Happy Sunday, everybody.